Can you all, if you can see this, could you put type plus to see my presentation? And also I'm recording this just for people who cannot come today. So my last presentation is about basically introduction of algebra and where it come from. Actually, this is a famous painting, just one on my right, is back then there are two schools of people making how do they do the computation. The one on the right is use some kind of calculate, kind of like a very simple calculator. So they actually is on a piece of cloth and they put the coins. They draw some lines, put the coins. It's kind of like the abacus, using abacus to do the computation. On the one on the left actually is using algebra. It's basically today we know as arithmetics, basically using the Arabic numerals and just write on a piece of paper and work out. So at the very early on, when the algebra was introduced to Europe, and you have these two schools competing against each other, but soon algebra just took over because it's way easier to do computation and and much more convenient. Uh, and so the reason we teach student algebra and is actually is to teach student how to think logically, how to reason logically. Like when you say something is true, then what kind of assumptions you have and what kind of rules you follow and how do you deduct, come to the conclusion. And actually that's the really purpose of teaching algebra. And the techniques, uh, all the problems and all that, I think most of us will never use it in our adult life. But by doing those computations, by solving these algebra problems, and we can develop a way of thinking things logically and a way of actually work out and come to a conclusion. And you see nowadays, many people struggle with that. Many people cannot think logically and unfortunately, a lot of students they don't just never actually really learn in the school. In the school, they just pretty much do the problems. And when I was teaching at the high school math teacher, my student always ask me, "What's the use? I'm going to using it." I just say that you are not going to use it. The purpose of teaching algebra is not for you so you can become a human computer. The purpose of teaching algebra that you develop the skill that you can solve problems, you can think logically, you can come to conclusions logically. And so that's actually the main purpose. We actually have algebra as a subject. But unfortunately, over the years, I think people um, has lost that the goal. They don't focus too much on the problems, on the how to do calculations. Uh, so, uh, so today actually I'm going to share with you what the rules of algebra. If we're going to think logically, we have to have a set of assumptions that everybody can agree on. It's kind of like in our Declaration of Independence, we said that we held those beliefs as self-evidence. So that means we don't have to prove it. This is what we agree on. That's our foundation. And therefore, then we have to, that's why we actually rebel against Europe, against the King of England, and therefore we want to establish a more perfect union. So they had that. Back then, those people actually had very good training. It's called classical education back then. They had that training to think logically. Unfortunately, nowadays we lost all we 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 lost many of that. Okay, so we're talking about rules algebra. Actually, rules algebra is pretty um, straightforward, and many things we probably just take for granted. And but this one at least allow us to see to make that more explicit. I'm trying to find my chat window. Sometimes it's kind of interesting. The chat window just go behind my presentation. Okay, see my chat window just disappeared. Let's see if we can do a little bit different. Okay, hopefully this is okay. Huh? The chat window is still not coming up. Okay. Where my chat? Yeah, it's just somehow behind the. Okay. Let's hopefully I can make that bigger and still have my chat. Okay. All right. Okay. Can you see my presentation well?
Yes.
This is okay.
But when you present, when you share your screen, you're not able to see the chat.
I know. I used to be able to. I used to be like the chat should pop up on the in front, but now the chat just behind it.
Oh, because from my experience, when you share the screen, you can't see the chat.
Oh, yeah, I was able to actually see the chat when I was teaching my students. Just like recently, I see this problem. The chat is behind it. Okay. Anyway, just like a quick kind of summary of what we did not for the last lecture, we talked about that arithmetic and algebra, they're totally different games. So the rules are different. And unfortunately, nowadays, we don't tell the student that we changed the game. The rule had changed. That's why a lot of students, when they come from the um, elementary school math, and actually, especially they are very good at it, and then all of a sudden get introduced to algebra, they got lost because they did not realize the rule. The game's different, the rule's different. So in the elementary school math, we call that arithmetic. It's a branch of mathematics, but it's more concerned with computation. It's like how do we add, how do we subtract, how do we multiply, how do we do divide? And the objective is make sure that the computation is correct. So that's basic computations. We need um, uh, to master. We need to be very good at it. But once we switch to algebra, we are more concerned about the properties of numbers and the relationship between numbers. And the objective is to actually to make sure if we give a statement, mathematical statement, we should be able to prove it is correct, it is true. And there is a reason behind it, why we say something like that. We have something behind it. So when we're solving a problem, like when we solve a linear equation, uh, we uh, let's see. Okay, so we see this is a quick simple one. 2x equal to 4. We know x is equal to 2, and the reason, if you think as a elementary school student, they normally think about, oh, because 2 times 2 is 4, so therefore the solution is 2, which is partial. This just means that we can verify it. Like we plug in 2, so 2 times 2 is 4. That's called a verification. That's not proving. The proving, we have to use the rules to make sure that x equal 2 uh, is not only x equal 2 is a solution, and x is equal to 2 is the one and only solution, given there are infinite number of numbers, and we have to prove that x equal 2 is the only solution. So that makes algebra very different from arithmetic. Um, are we okay so far on this one? This is kind of a recap of the last lecture.
Yes.
Okay, if you're okay, could you type plus? Yeah, if you're not
Can I just say yes?
yeah, you can say yes. If you're not computer, it's hard to do that.
I
Yeah,
was like trying to look for screen.
I know. Okay. So let's do look at that. So next one. So now we're going to looking at rules. And actually, it's not that many. It's just 10 rules. The rules actually concerns with the two operations. One is addition and one is multiplication. And later on, I will show you why we just only consider these two. And because subtraction is a form of addition and division is a form of addition. And once we got algebra, we can see why is that. Um, so now, given those, we have, okay, let me go back. Yeah, we have 10 rules and separate 5 for addition, 5 to multiplication. And I think you probably heard about that. And actually, sometimes in elementary school, the kids get exposed to that. So the first one is called commutative. Commutative actually pretty easy. It's basically saying a number, add another number, and the order does not matter. So we know 4 plus 5 is same as 5 plus 4. So that's basically the property of addition, the operator. We call this the operator. Okay, and on the multiplication side is a number times another, and we can swap the order. So it really doesn't matter. So like say 3 times 7 will be the same as 7 times 3. So very pretty obvious, but it's very important to make that explicit. Because now we know what we are based on when we're doing algebra. So that's the first one. Uh, then we have called associative property is that A, we got A, B, and C. We can do A, B first, or we can do B, C first. That order does not matter. So any of them can associate. Um, And the same thing for multiplication is that if we have A times B times C, then we can do A times B first or um, B times C first. And really the value is the same. So the operation, basically now we're talking about the properties of the operator, in this case multiplication. And this one does give some advantage. And even this one, like say sometimes when we do mental math, we can do 3 plus 9 plus 7. You can add 3 plus 9, 12, plus 7 is 19. Or you can just do 3 plus 7 is 10, 10 plus 9 is 19. So that's the trick we're actually going to use when we do mental math, like use our head to do it. We use that property. Same thing for here. We could have, say, 2 times 7 times 5. We can do 2 times 7 is 14, 14 times 5. We know is 70, or we can just do 2 times 5 first, which is 10, 10 times 7 is 70, which is a lot easier for our brain to operate. So that's some applications of the simple basic properties. So now we have 4 already. So the next one is called identity property. Is basically it's a number adding a 0 is itself. So adding a 0 does not change the value. So this one we know, we probably take for granted. But again, it's good to make that explicit. So basically we are kind of explicitly write out all the assumptions. Those things, some things we assume on, we assume they are correct. We're not going to prove it. We assume they are correct. Then based on that, we can prove something on top of that. The same identity property is this, is A times 1 is the number itself. And then now you can see the language algebra, we use the letters to represent numbers. And we know that 9 times 1 is 9. And so those are the properties. And then we're going to get down to the inverse property, and which is very, very important when we do solving linear equation, is a number adding its opposite is 0. So it doesn't matter what number it is, as long as it's a number. We could have 5 plus negative 5 is 0, or we could have 2/3 plus negative 2/3 is 0, or even pi plus its opposite, negative pi, that's still 0. So very important property. It's called inverse property. Another one for multiplication is this. It's a number times its reciprocal is 1. And so we got, say, 4 times 1/4 is 1, or pi times 1 pi is also 1, because we have that property. And this property has exception. The exception is that a cannot be 0. So we cannot divide by 0. Okay, this is a very, very important rule in algebra is we just cannot divide by 0. Divide by 0 is not defined. We are not saying it's not. It actually is something, but it's not defined, and this does not follow the rule. So this is a divide by 0 is outside the rules of algebra. But interesting enough, once we got to a calculus, we're actually going to attack this problem. It's like how actually dividing by 0. Okay, now we go to the last two. It's called distributive property. It's something like this. It's, if we have something like this, then this is the same as A times B plus A times C. Or we can do the other side. This is from the left. This is the left distributive property. And we could go from the right-hand side, which is called the right distributive property. So it's A times C, then plus B times C. And those properties are very important later on in order for us to solve equations. Okay, are we good here so far? And if you're good, could type plus. Or if you have any questions,
Yes.
you can ask. Okay. All right. All right. So we can, yeah. If you have any questions, you can always just type a question mark. And actually, there is I think you can also put raise your hand. There is a symbol for that. Okay. Now we got on to the next one is this is talking about properties of equations now, equality. And we also have property of the inequality, but we are not going to talk about that yet. Properties equality, this means like if we have equation, what kind of properties we have with that equation. So the first one is called addition property. That means if A is equal to B. So we don't care what they are. So you see that this is the language algebra. We're going to use if-then structure a lot. We just say if this is true, and we don't even care if it is really true. We just say that if it's okay when this is true, A equal to B. It doesn't matter what number. Then this has to be true. So the next one has to be true. That's what we mean. This is a logic structure. If then A plus C equal to B plus C. So if we have equation, then we can put the same thing on both sides of the equation, and the equation is true. So if this is true, this has to be true. Okay, if we find out somehow this is not true, then which means this is not true. This is called the premise. I hope I got right. I'm not sure. I probably have a spelling error. It's basically this is what's given. It's given, we assume this is true. But if we assume this is true, then this has to be true. So it's called addition property. And this one we're going to use that a lot. Another one is a multiplication property. is that if A is equal to B, so we have an equation, this is true, then we can multiply the same number on both sides. So for example, 4 is equal to 4, we know that. But if we times 5 on both sides, then the equation is still true. But if we time different number, the equation is not. So 4 times 3 is not equal to 4 times 2, because those two numbers are not the same. But as long as we have the same number on both sides, the equation is true. And this actually is the heart of algebra. It's the reason that we can solve algebraic problems is because the properties of equality. And now the last one is called zero factor property. It just says that if two numbers multiply equal to 0, now there are only 3 possibilities. Is A equal to 0, or B is equal to 0, or both, and A equal to B equal to 0. And that's only 3 possibilities, nothing else. And that we're going to use that also when we're solving algebraic equations. Okay, are we good so far? If you're good, could you type plus or just say good?
Yes.
Wonderful.
Yes.
And now, okay, yeah. And now we're going to looking at how do we use that for solving linear equations. And okay, and I'm also going to show you what kind of the rules we use and properties we have. So the simple linear equation we just had that, in the beginning is 2x equal to 4. So this one just saying if this is true. So what we're going to do, we're going to multiply half on both sides. And this one we are using the property, the multiplicative property that if A is equal to B, so A times C is equal to B times C. Okay, that's the property we used. So, and that's the way we do algebra is every time when we say something, we have reason behind it. We are based on certain rules. And so if that's the case, we know half times 2 is 1, right? We know that rule. Yeah, that's A times 1 over A. A number times its reciprocal is 1. That's the one of the rules. It's called the multiplicative identity. So now we have what 1 times x equal to, now 4 times half we know is 2. And then we know 1 times x is x because we have this rule 1 times A is equal to A. So therefore x is equal to 2. So now we are saying by following these rules, we only find one solution. We didn't find any other. This is the only one. Now, because we follow the rule, and it's the only one among infinite number of numbers. So are we good on here?
Good.
Okay, so I'm going to show you another linear equation and show you the rules we follow. Okay, another equation is if we say 2x plus 4 equals to, let's say 10. And now we're going to use this, adding minus 4 on both sides. Okay, and the reason we can do that, remember we have this property, if A equal to B, then A plus C equals to B plus C. That's one of the properties of equation. So we can do that. And then on this side, we know 4 plus negative 4 is 0 because we have this, A plus negative A equal to 0. So therefore, on this side, we got 2x plus 0. On this side, this one is 6. Now, on this side, we have this rule, A plus 0 is a number itself. So therefore, this is 2x equal to 6. And now we're going to follow what we had before, times the reciprocal, and we know we can do that. And then this gave us 1. 1 times x is x. On this side, 6 times half is 3. So now by following the rule, we said this is one and only. One and only, nothing else. One and only solution. And once we arrive, once we got this solution, which basically is our conclusion, then we can verify it. Verification. The verification means we can plug in the value of x, which is 3, plugging back. So 2 times 3, that's 6. Then 6 plus 4 is 10. So we know we are right. We know that the solution, this solution is the right solution. So not only we know this is the only solution, and we also verify that it indeed it is a solution. Okay, we are good here.
Dr. Ping, I do have a question here.
Sure, go ahead.
Yeah, I understand what you're saying. But can we assume if A equals B, A minus C equals B minus C, so we don't have to plus -4? Can we just
Yeah, you
take
can
off 4?
yeah, you can minus 4. You can minus 4, and that just kind in a way is kind of like a shortcut.
Right. But I mean, in Common Core, I mean, is this what the students are taught? Like they have to use not the shortcut. I mean, eventually they would just do the shortcut, but if they have to prove the question, do they have to write like plus -4? I mean,
I don't know. Yeah, I'm not that familiar with Common Core, and just from what I heard, I think people who came up with Common Core, they actually tried very hard. But just like when it was implemented, that caused a lot of confusion. And
right.
Personally, just based on my experience, with my students, that I think the biggest problem right now is that they are pushing too much too early, and they need to give the kids the time to develop, just to go with their mental develop stage, because the kids they are growing, and but the principle of that follow every step itself, I think, is good. And like this one, I followed every step. But once we understand it, then we can just take shortcut.
Right.
But as long as we know what we're based on. Actually, we have some time. I want to just go talk a little bit about why we only have addition and multiplication.
Wait, before you go, just to answer her question with Common Core,
Yeah.
It's best to not do shortcuts, just in case there is an error and the teacher is able to identify in what step the error took place. Also for partial credit.
Okay. Thank
Yeah.
you.
Okay. And one thing I heard about Common Core is that they sometimes gave different ways to solve the same problem. And it's good in a sense, but also cause a lot of confusion. And the kids need to have something solid they can grab on, and then they can build on top of that. But now it becomes so too much, so the kids really just kind of a little bit get lost. But anyway, that's something we can talk about in other times. But I do want to conclude with this, with why we only looking at this too. Because this is only when we get algebra. The reason we only can do that is because in algebra now we are dealing with number called the real number, and this is not really the concept that like integers. Integers, we got positive and negative, and this one is a little bit harder for elementary student. I mean, a lot of kids can get it, but there's some kids have some trouble. And but the way we can say, okay, subtraction is a form of additions, because we have this positive and negative numbers now. And next time we're going to talk about the number families, positive, negative. So therefore, a minus b we can write as a plus negative b. So negative b is opposite of b. And that's the concept in algebra. Sometimes if we push too early, then kids will get confused. So that's why we're only talking about addition. And that's why we'll also have something like this, like say 4 minus 6. Now, definitely that's not equal to 6 minus 4. that's not correct. But we can say 4 minus 6 is 4 plus negative 6, which is the same as negative 6 plus 4. And you see that the rule applies. That works for that too. But you have to realize this. Then multiplication is also because we have called the rational number. That's because we can represent number in kind of just fraction, which is fraction is part of that. And so we have something called the reciprocal. So like 3, the reciprocal 3 is 1/3. Or pi, the reciprocal is 1 over pi. So therefore, like say 4 divided by 7 is the same as 4 multiplies by 1/7. So that becomes multiplication. And you'll see that why we do that, because remember the rule we have, if A is equal to B, then A times C is B times C. So now we know that 4 divided by 7 is not, 4 divided by 7 is not 7 over 4. That's not. But if we write in the form of the reciprocal, we write as 4 times 1/3, 1/7, then we can flip it. We can say it's the same as 1/7 times 4. So then that the rule of A times B equal to B times C, then that rule is still valid. Okay.
Okay.
All right, great. Any other questions?
No.
No, good.
Okay, so next time we're going to look into linear equation and also look into quadratic equation, and that basically forms the basics, the base of algebra. Then everything else is built on top of that, and we always simplify the problem back either to linear, actually back to linear equation. You'll see that no matter what kind of problem we have, we can always simplify that into the simple equations we know how to do, and that also give us the confidence that what we do new, what we are doing is follow the rules, and our rules are sound. So therefore, the conclusion we come to has to be true. Okay.
Okay.
All right.
All right, great.
See you, yeah.
Thank
See you next
you.
time. You're welcome.
Okay.
Thank you. Have a great week. Thank you.
Yeah, you too. Bye.
Thank you, Dr. Pink.
Bye.
Bye.